So it started?
Mm-hmm.
Okay, you said that you have not heard about mutually exclusive events.
Yeah.
So I'm gonna try example here. For example, let's talk about roll a dice. Roll a die.
Mm-hmm.
Do you remember if you roll a die, how many possible outcomes?
6.
6. So the outcome, I'm calling that S as its sample space. So it's 1, 2, 3, 4, 5, and 6. Now, in probability, we calculate probability of an event. So you have to collect a few outcomes and call that an event. For example, let's use A to represent the event of having odd number of outcome. And then how many outcomes does that include?
3.
And they are 1, 3, and 5. Okay. So when you try to calculate probability, you would do probability of A. So what is the chance is odd? What is the probability for odd outcome?
50%.
How do you know it's 50%?
Because 3 is half of 6.
So 3 out of 6. So the part that belongs to event divided by the total number of outcome.
Mm-hmm.
All right. So that gives us 1/2 or 50%. Or you can also write it 0.5. All right. We call that the proportion, that percentage, and that's a probability. But they all start with a P and they all mean the same value.
Mm-hmm.
And that's the definition for probability about mutually exclusive. Odd event involve 1, 3, and 5. Now, I'm naming a different event B. Let's say event B represents having an outcome 4. So, does A and B have anything in common?
No.
In that case, we would say A and B are mutually exclusive. All right?
Okay.
And in this case, how do we represent mathematically that they are mutually exclusive? We would say the probability that A and B, that's the notation for and, it is equal to 0. Because there's 0 chance for a die to be both one of the odd number and a 4.
Okay.
Because it's impossible, we see that probability is 0.
Yeah.
And also, we use this to define or to determine mutually exclusive. Whenever two events is mutually exclusive, that's when their AND event has a 0 probability. Is that okay?
Mm-hmm.
Okay, so that's for mutually exclusive. Another important concept is independent. What do we mean by independent? Independent is when one event, A and B, A does not affect B, does not affect the B's likelihood. Okay?
Mm-hmm.
For example, let's say the probability for A, which is odd event, is 1/2. Okay, now that's in this set. Now I'm picking a different one. Let me call that C. All right, and C is a collection of 1, 2, 3, 4.
Mm-hmm.
Okay. So what's the percentage of C that's also odd? This is called a conditional probability. Mm-hmm. You're not talking about how many odd is in the total of your rolling a die. We're talking about the probability of odd, A represent odd, in the C set. And this is called conditional probability.
Uh-huh. And that's 3 out of 4?
How many odd is in the C?
Oh, 2 out of 4.
So it's 2 out of 4. And that is also 1/2.
Mm-hmm.
So what does that mean? That means probability A and probability A inside C, they're the same. Which means in C or not in C has not had effect of A. And that's when we say A and C are independent.
This is a lot of work.
You get what I'm saying? So that's the meaning of independent.
No,
So-
Sammy, go away. Go.
So probability A and C, which means it is in A and it's also in C. What is this? What's the chance a die is in the set A and it's also in C?